Hello everyone. In this video, we are going to see an introduction to AC circuits. The AC is abbreviated as alternating current, and it is quite popular because all our home utilities and it's clearly with alternating current of distribution. So we use all electrical equipments. So it is necessary to understand the AC electrical parameters and circuits for determining the electrical parameters. Let me get into the video content. Right. So with an introduction to AC circuit, uh, instead of DC source, we are going to give a AC source to the circuit. So there will be a current, there will be a voltage, there will be a resistance. There is no change of part here. But only change with the AC and DC is a DC do not have a frequency and AC have a frequency. And also one of the thing which is added in the AC is power factor, but which will not be the power factor will not be in the DC circuit. Okay. So here are two graphs are shown for differentiating the DC and AC waveform. Okay. So this is measured. Okay, this is an AC waveform and this is a DC waveform. These two things are measured with the help of cathode ray oscilloscope, where we used to measure the signals and automatic plot of graph which will be displayed in the cathode ray oscilloscope. Oscilloscope will measure the quantities of AC and things that will be shown over here. So this is a simple introduction to AC circuit. And AC circuits have classified into three types. One is single phase, another one is a three phase. Single phase in the sense there will be one phase only available. In three phase, there are three phases are there. In a single phase, the positive of cycle will be there and the negative of cycle will be there. And for each 180-degree, the waveform will become zero. Okay, and it flows on. But in case of three phase, so R, Y, B, and three phases are there. So let us check the phase R here. Okay, when R goes maximum positive and 180 at 180 it becomes zero, and at 360 again it becomes zero. But at the time of R phase is becoming a zero, the yellow phase and the blue phase will be the maximum voltage. Okay, so three phase AC supplies are very dangerous to the human when we consider with the single phase supply. Okay, so these are the three things here in the three phase lines and one neutral will be there. Okay, so this is simple changes over it. And as I mentioned, there is a frequency in AC. Okay, so let us understand what is the frequency. Okay, so I have shown a single phase sinusoidal waveform with a one positive cycle and one negative cycle here, which is called as a one complete cycle. Okay, so one complete cycle which can be mentioned as a time t. For one complete cycle, the time is mentioned as t. So here a positive cycle and the negative cycle is there. The frequency of the line can be calculated by 1 by periodic time. So that means frequency f is equal to 1 by t. The unit of the frequency is hertz. Okay. So we can generally write the find the frequency or the time period with the help of this relation. Either we can say periodic time is equal to 1 by frequency, or the frequency is equal to 1 by time. So with this thing, we can calculate the frequency in a AC source. In India, the 50 hertz frequency is used, but where in the abroad, like 60 hertz frequencies are used. Okay, things, right. And another important factor is peak value or maximum value in the AC cycle, AC waveforms. Okay, the maximum value attained by the alternating quantity, that means AC supply, during one cycle is called as a peak value. Okay, so in this diagram, there is a black arrow mark which is shown as a peak value. Okay, see here in the positive cycle at the 0 degree, an AC source, AC waveform is starting and gradually it is rising and reaching to the 90 degree maximum at the 90 degree. So when we measure with a 90 degree, so that value is called as a peak value. Okay, it is also called as maximum value or amplitude or crest value. Okay. And the second thing is RMS of AC line. RMS value. It's a root mean square value. It's an effective value of carrying the voltage and varying the voltage or a current. So we all know what is peak value, what is amplitude, or what is average value. Okay. So when we divide with the root 2, okay, when we divide the peak value divided by root 2, then that is exactly called as a RMS value. Okay. So peak to peak value, which can also be mentioned via graph. And see here, VRMS is equal to 1 by root 2 into V peak. That means peak value divided by root 2 is the VRMS value. So 1 by root 2 can be generally written as 0.7001. Clear? And as I mentioned, the power factor. The power factor is a cosine angle between the voltage and current. In other terms, it is mentioned as a ratio to the real power to the apparent power. Okay. And we can see this relation where the triangles over here is mentioned as kVAR, kVA. It's a real power and a reactive power and the relation of kilowatts. So power factor is equal to actual power by apparent power. In other terms, power factor is mentioned as a cos phi. Okay. And where the government is actually putting fine to all industries, the maximum value to the power factor is 1. If an industry maintains the power factor less than zero point 0.8, then the TANGEDCO or Tamil Nadu Electricity Board will put a fine to the industry because of maintaining the less power factor and increasing the reactive values of the line. Okay, so these are all the few things in the AC, and let us see the power formula in the AC circuit. Okay, so let us have a single phase AC as the first thing. The power can be, as I mentioned, there is a power factor existence in the AC, the product of voltage, current, and the power factor. Okay, there are three different expressions as shown for calculating the single phase power. P is equal to I square R into cos phi, V square by R into cos phi, and power formula for three phase is root 3 VLI cos phi. And when we have phase value, consider a phase value, then 3 into V phase I phase cos phi are to be used. So these are the different forms of power formulas in an AC circuit, which we could apply into these circuits, and we can determine the electrical quantities of AC power. You can refer these books to get more knowledge on the AC quantities.